So friends, till this point we have discussed what is hypothesis test, and we took this example that one friend of mine, and his name is Lakshman, and he has said, he has proposed that he can hit 6 sixes in 6 balls. Okay, so now Lakshman proposed hypothesis, and the another friend of mine, he wants to test it, and that is my hypothesis test. So we have discussed that for every test we need a scale. Okay, and there can be only two possibilities with the test: either the test will be qualified or it can be disqualified. But how we will find out, how we will measure that the test is qualified or disqualified? For that we need some parameter. Okay, and statistically that parameter is p value, and p means probability. Okay, so p value is your probability value. Okay, so now when I say probability, so we have discussed all these things. Okay, so let us suppose, as Lakshman says that he can hit 6 balls, 6 sixes in 6 balls. Now, um, the very first ball he hit a 6, and the second ball again he hits the 6. Okay, so now what I'm saying that okay, Lakshman, leave 6 ball. Even if you hit 4 sixes in 6 ball, I will agree to you. I will agree to you that yes, you have that capability that you can hit 6 sixes in 6 balls. Okay, and this happens in our real life as well. Okay, if I take an example, let us suppose I said that I can complete this task in 8 hours. I can complete. Uh, okay, so do one thing. Let me write. Okay, I said I can complete some task. Okay, in 8 hours, or you have said this. Now your peer is saying I can complete uh, the same task in 4 hours. Okay, so now you will say that okay, let's agree to a point. Forget about 8 hours, forget about 4 hours. Okay, so I'm saying if you can complete the task even in 6 hours, even in 6 hours, you are better employee than me. So what is happening here? Here we are coming to a agreeable point. Okay, so in this stage, I'm saying this actually happens in our life, real life, that I I said that I can complete in 8 hours, and the one saying I have 4 hours. So I said no, okay, take 6 hours. If you do that job in 6 hours, I will agree with you, and you are the better person or better employee, or your performance is better than me. So we are getting agreed somewhere. Okay, we are getting agreed somewhere. So now, if I talk about the probability, probability is a variable thing. Probability is variable. Why? Because with each trial it will change. As I told you, okay, if it is 8 by 10, okay, first time when I gave the 11th time, when I I put an effort, so at that time Either I will get success or I will get failure, but this data will change. Okay, either denominator will change, either or numerator and denominator both will change. Okay, so it is probability is a variable, but your scale or your parameter, they are fixed. Why they are fixed? Because we have fixed a benchmark, isn't it? We have fixed a benchmark, and benchmark that benchmark is our p value, which is equals to 0.05. Oh, just a minute. To 0.05. Okay, so we have to remember this thing, that benchmark is our p-value and which is equal to 0.05. 0.05 means 5%. Okay, it is 5%. See, we fix some benchmarks. Okay, so if we have to quantify something, we have different scales. We have meters, we have centimeters, we have feet, foot, we have palm length, we have kilometers. There are so many things, but all these things are agreeable internationally. Okay, if I count something and if I say this is 9 centimeter, so this is agreeable by everyone because I'll show them scale. That scale is agreeable by each and everyone. Okay, so in the same way, this p value, which is 0.05, means 5%. This is conventionally agreeable or agreed by everyone in this globe. Okay, it is not mandatory that it should be 0.05. You can have something, you can have some other values as well. You can have 0.01, okay, or you can have, let us say, 0.10 means 10%. Okay, in this case it is 1%, so it can be, but it has to be agreed by everyone. And this p-value, which is 0.05, it is agreed by everyone. So this is a parameter, setting a parameter. Now, for example, we can say that in some universities, the passing criteria is 30%. In some universities, it is 35%. In some universities, passing criteria is 40%. Okay, so that is, they are fixing the parameter that if this student score more than 40%, then only he will be considered as passed, isn't it? So this is happening here. Okay, but how we will get agreed on this? Either it is 0.05, either it is 0.01 or 0.10, either it is 5%, 1% or 10%. How we will agree on that? So we will get agree. We get agreed on this. Why? Because with that term is known as level of confidence. Okay, so when I say level of confidence, what it means? Let us suppose for anything, let us take this previous example only. Okay, so as we discussed that this is point A to B. Okay, and in 10 minutes I have to reach from point A to point B. If I do that, I'm successful. And if I take more than 10 minutes, then what? Then it is a failure. Okay, so let us suppose I tried 100 times. Okay, and out of this 100 times, hmm, 95 times I got success. Okay, and five times I got failure, or I got fail. So now if I say my p here, my p value will be 95 by 100. Can I say that? Yes. Okay. So my p time p will be 95 by 100, or my p value. Okay. So actually I tried 100 times total number of events and I got success 95 times. So 0.95 I can say, or I can say 95%. So this 95% is my level of confidence. This 95% is my level of confidence. And if my level of confidence is 95%, if my level of confidence is 95%, then I must agree 0.05 means 5% of failure. Getting the point? If I'm 95% confident, it means 5%, still 5% I'm not confident. I might fail, 5% is the probability, but 95% I'm confident. Okay, so this is my level of confidence, and this is this value we have taken 0.05. Okay, that my if my p value is 0.05, this is I have taken. So now this 0.05, what is this? This is my, actually when we write 1 minus level of confidence, it becomes equals to level of significance. Level of significance. So that 0.05 is my level of significance. So let us try to understand what we are saying right now. So go ahead. Okay. Let us suppose this is 100%. Okay. I'm dividing these two things into zones. Okay. And this is my 5% zone. And this is my 95% zone. Okay, so now if I fall in this zone, if I fall in this zone, then it is my I can say that I'm getting success. Okay, and if I'm falling at this zone, then it is a failure. Then it is a failure. Let us suppose my p-value, my p-value, it came 3% till here. So I'm falling in this zone. Are you getting it? I'm falling in this zone, so it is a failure. Again, it is 4%. Again, it is under 5%. So again, it is in failure. But let us suppose it came out of this zone. It is 10%. So I'm in this zone. So it is a success. So I can say that this zone is my level of confidence. This is my level of confidence. Okay. And this zone is my level of significance. Okay. So now it's up to us on which zone I will fall. Okay. So if so hypothesis, if I talk about hypothesis, okay, let me do it here only. So if I talk about hypothesis, so when I proposed a hypothesis, that is known as my null hypothesis. That is known as my null hypothesis, and which is denoted by H naught. Okay. And when I'm challenging it, when I'm trying to test it, then it is known as my alternative hypothesis, and which is denoted by HA. Okay, so when my p value, is greater than 0.05. Now concentrate here. When my p value is greater than 0.05, in that case, H naught, which is my null hypothesis, it is accepted. Okay, it gets accepted because I am coming out of this zone, because I said that if my p value will be greater than 0.05, and if 5% means 5%. So if my value is greater than 5%, so I will fall in this category, in this zone. Okay, and here this is the success, means my null hypothesis is accepted. Okay, and when my null hypothesis is accepted, in that case my alternative hypothesis, it will be rejected. Okay, and if my p value is less than 0.05, means 5%. If my p-value is less than 0.05, it means where I will fall? I will fall in this zone, okay? So in that case, my H naught, it will be rejected, and my alternative hypothesis, it will be accepted. So if p-value is 0.05, or I can say, if I'm saying that my null hypothesis H naught is accepted, what it means? It means that what has stated is proved. What has stated is proved. Means when Lakshman says that I can hit 6 sixes in 6 balls, and I set a parameter, we came to the agreeable point where my p-value is 0.05, or we came to the point that, oh, no, forget about 6 balls. If you can hit 4 sixes in 6 ball, I'm ready to accept that you are capable. You can hit 6 sixes in 6 balls also. I'm agreed with you. Okay, so I set that parameter 4 balls. 4 sixes means if you can hit 6 in 6 balls, if you can hit 4 sixes, I'm agreed. So that 4 is my 4, which I set the parameter, that benchmark, that is my p-value, and that p-value is 0.05. Getting the point? Okay, so here the null hypothesis is Lakshman says that I can hit 6 sixes in 6 ball, and I said no, p-value is 0.05, and you say you can hit 4 sixes only in 6 balls. I will agree to you. And if he hit 4 sixes, so what he said, what Lakshman said, that is accepted. That is accepted. And what I said, that I'm going to test you, I don't believe you. So my hypothesis, alternative hypothesis, which I gave HA, it got rejected. Simple. Getting it or not? Okay. So it got rejected. But if p-value is less than 0.05, if my p-value will come less than 0.05, in that case, my null hypothesis is rejected. Means Lakshman said that I can hit 6 sixes and 6 balls. I said, okay, forget about 6 balls, hit 4 sixes and 6 balls. I will agree to you. But he, just a minute. Yes, but he was not able to prove. He was not able to hit even 4 sixes and 6 balls. So what will happen? Because we both agreed on 4 sixes and 6 balls, but he couldn't make it. He hit only 2 or 3 sixes and 6 balls. So in that case, what Lakshman says, what he said, Lakshman, it got rejected. That H naught, null hypothesis, it was rejected. What he proposed is rejected. And what I said, that I don't believe you. Okay, here you see, I don't believe you. So I challenged him. I want to test him. Okay. So the hypothesis which Lakshman gave us, that I can hit 6 sixes and 6 balls, I challenged him and he was not able to prove it. And that is why my alternative hypothesis, it got accepted, that I don't believe you and you can't. Okay. You are, just saying in the air, and it is proved that you cannot do it. Getting the point? So this is null hypothesis and alternative hypothesis. Okay, so this level of significance is my 0.05%. If I uh, okay, let me take you to the uh, our bell curve, normal distribution curve, if you remember. Okay, so okay, just a minute. Let me do it again. And sorry. So let us suppose we all know in bell curve, uh, this point, center point is our, what is this? This is our mean. Okay, so I'm taking a single tail test here. So I'll tell you later what are single tail and right tail, left tail. So it is right tail test. So this is tail. Okay, as we all knew, as we all know, we discussed in skewness. Okay, we all know skewness. So this is left tail. This is right tail. So let us suppose I'm taking this one. And this line never meets with this x-axis, this line. Okay, so it will be like this only. So let me try to draw it. Okay, so this will come like this. It will never meet this line. It will go parallelly later on. So I'm doing this. This one. And here also. Now, so let us suppose till this point, it is 95%. Okay, so till this point, this is my 95%, and rest is my 5%. So what is this? This area in bell curve, this is my level of significance. Okay, and this level of significance, which is 0.05, means 5%. And this level of significance, it is also denoted by alpha. Okay, so it is denoted by like this. Alpha. Okay, and this red area, it is my level of confidence. So now it's up to me that according to my p-value, where I will fall. Either I will fall in this area, this red area, then this will be my level of confidence, or I am falling in this area, this blue area. This is my level of significance. Okay, if I will fall in this area, then null hypothesis will get rejected. Because what when I challenged Lakshman, when XYZ challenged Lakshman and he said that I do not believe you. So if Lakshman tries 6 balls and he's falling in this criteria, blue criteria, in this level of significance, it means he was not able to hit 4 sixes and 6 balls. Okay, but if Lakshman hits 4 sixes in 6 balls, then he will fall in this criteria. So in that case, if Lakshman fall in this criteria, if he can hit 4 sixes and 6 balls, so I am out of this zone, 5% area. I'm out of this level of significance. I proved it. I crossed this barrier of level of significance, which is 5%. So I will fall in this area. Getting this point? Okay. So this is for the single tail. This is right tail. Okay, this is right side of the bell curve. This is left side. So this is single tail test. Okay, but we do double tail test as well. So in that case, what will happen? In that case, this thing will happen. Okay. So let me just a minute. Let me select. Okay, and copy. So in two tail test, what will happen? Now this thing will happen. Okay, so this middle area will be my level of confidence and level of significance, because level of significance is 5%. Okay, so this will become my so this will become what this will become. Just a minute, give me a second. So this area will become alpha by 2, because now this level of significance is divided into 2 parts in a 2 tail test, because this left tail also and this is right tail. Okay, so this will become how much it will become? 0.025. Okay, and this will also become 0.025. Okay, means this is also 2.5%, and this area is also 2.5%. So again, this is alpha is divided by 2, level of significance is divided by 2. Okay, so this will happen in the case of two tail test, because we have left tail as well and we have right tail as well. Okay, and the middle area, this will be my level of confidence. So again, we have to check either we are falling in this area, blue area, or we are falling in this area, red area. Level of confidence. If we fall in level of confidence, then null hypothesis is accepted. And if we fall in this area, blue area, it means alternative hypothesis is accepted and null hypothesis is rejected. Okay, so whenever my p-value will be less than 0.05, it means alternative hypothesis is accepted. And what Lakshman says, he couldn't do it. Okay, and but if my value is greater than 0.05, if it is greater than 0.05, then it is greater than 0.05. So we are falling in this area, level of confidence. We are falling in this area, level of confidence area. So it means Lakshman is 95% confident, and he did it on the basis of parameter which we fixed, that is value p value will be 0.05. He did. He hit it 4 6s in 6 balls, and that is why p value is greater than 0.05. He is falling in this area. So null hypothesis means when I challenged it and I said, I don't believe you. At that time, I was wrong because he proved. Okay, Lakshman proved. How it proved? When my p value is less than 0.05. Oh, sorry. It proved when my p value will be greater than 0.05. Okay, so he will fall in this zone. So I hope you got it. What is hypothesis? What is hypothesis test? What is scale? What is parameter? And what is p-value? Okay, the level of confidence, the level of significance, and what is null hypothesis? What is alternative hypothesis? When we have to accept null hypothesis and when we have to reject null hypothesis, both the cases. Okay, so the parameter is our p-value in that case, and this is our single tail test, and this is our double tail test. I hope you got this, but still, if you will be having any queries, any point you want clarification, you can call me, you can message me, you can email me. Okay, I will I'll take you out of that dilemma. Okay, so I'm stopping here then. Okay, so take care. Bye bye.